Let's talk about system of equation in two variables. The system of equation in two variables is a system of equation of the form ax plus by equals c, where a and b are not both 0 at the same time. The solution of the system of equation is an order pair xy that make each equation in the system true. And we can solve the system of linear equation by graphically, we can do a substitution or elimination method. So we will start with solving the system using the substitution methods. And I have this example problem here for you with layout step by step for you to follow. Please do that at your own time. I'll go ahead and try and show you how to solve our next example. We want to solve all solutions to the system. So the first step in solving the equation using substitution is to solve for one variable in one of the equation. So let's call our first equation here equation 1, and here's equation 2. From equation 1, x plus 7y equals 0. I will solve for x in this equation. So subtract both sides by 7y. So x equals negative 7y. I will substitute this result into equation 2. And by doing that, I get 2 times negative 7y minus ay equals 22. So y equal to negative 1 here. We will use this result to solve for x. So we know that x is equal to negative 7y. And we just solve for y here. We got y equal negative 1, which means x equal to negative 7y times negative 1 equals 7. So the solution to the system is the order pair 7, negative 1. Again, let's take a look at the next problem. So here, note that we have a fraction. Okay? And I know how much we love working with fraction. So before we do this problem, let's go ahead and try to clear fraction. So here we will clear fraction. By multiplying the second equation with 2. The reason I multiply by 2 because here's the denominator equal to. So then our system of equation become 9x plus 15y equal negative 6. And multiply this equation by 2, we get 4x plus 5y equal negative 6. Okay, now I'll mark this equation 1 and 2. So I'll go ahead and start with the equation 1. 9x plus 15y equal negative 6, and I'll go ahead and solve for x. 9x equal to negative 6 minus 15y divide by 9. X equal negative 6 over 9 minus 15 over 9y. Simplify fraction. So negative 2 over 3 minus 5 over 3 y. I'll go ahead and substitute this into equation 2. So now I get 4 times negative 2 over 3 minus 5 over 3y plus 5y equal negative 6. I will go ahead and distribute the 4. So negative 8 over 3 minus 10 over 3y plus 5y equal negative 6. Again, I don't like working with fraction that much, so I go ahead and clear the fraction by multiplying the whole thing by 3 to get negative 8 minus 10y plus 15y equal negative 18. Combine like term. Solve for y. Now that we have y, we can go ahead and solve for x. Okay, we know that x equal to negative 2 over 3 minus 5 over 3y, and we just got y equal negative 2. So negative 2 over 3 minus 5 over 3 times negative 2 . So x equals 8 over 3. So the solution to the problem is the order pair 8 over 3, comma, negative 2. The next thing we want to look at is to solve this by using substitution. We will solve the system of equation by using elimination method. So the elimination method, the goal is to try to get rid of one of the variables first, okay, and we use that result to solve for the other variable that is left over. So let's go ahead and take a look how this problem would work. We want to find the solution to the system 4x minus y equal 20 and negative 2x minus 2y equal 10. So what I want to do here is I want to eliminate in y. Now it doesn't really matter if you want to eliminate in x. You will get the same answer either way. It depends on what you think and what go through your head when you solve this type of problem. So eliminating y first or x first does not affect the result of the problem. So here what I want to do is to eliminate in y. In order to eliminate y first, so looking at this pair, negative y and negative 2y. If I want to eliminate in y, I need to make it so that it becomes the opposite sign, right? So I need to make the first equation to become positive 2y. So I want to make the first equation to be positive 2y. So I multiply equation 1. I multiply equation 1 with negative 2. So then the equation 1 now becomes negative ax plus 2y equal negative 40. Okay. So let's just write the resulting equation, negative ax plus 2y equal negative 40. So the system now becomes negative 2x minus 2y equal 10. And I'll go ahead and add this together. So negative 10x plus 0y equal negative 40. Note that we successfully get rid of y. So we solve for x here. So negative 10x equal negative 30 here. Equal negative 30, which means x equal 3. Now that I get x equal 3, I can solve for x by taking x and substitute it into either equation 1 or 2 to solve for y. So I'll go ahead and substitute x equal 3 into equation 1. So 4x minus y equal 20. This means 4 times 3 minus y equal 20. So y here is equal 8. So the solution to the system is 3, 8, the order pair. Now, before we do elimination or substitution, it's always best to try to see if we can simplify the equation to start with. So for example, in this next equation, 8x minus y minus 20 and negative 16x plus 7y equal 30. Note that the first equation can be simplified by 2. So if I go ahead and simplify the first equation by 2, I should get 4x minus 3y equal negative 10. Negative 16x plus 7y equal to 30. So what I'll do here is I will try to eliminate x in this equation by first multiply the equation 1 by 4. Okay, so then my system now becomes 16x minus 12y equal negative 40. Negative 16x plus 7y equal 30. Now if I go ahead and add this together, note that I get 0x minus 5y equal negative 10, y equal 2. Now that I have y, I can plug it into either equation 1 or 2 to solve for x. So then 4x minus 3 times 2 equal negative 10. So the solution to the equation is the order pair negative 1, 2.